Hola mi clase. Hola mis estudiantes. So we're doing 7-2. I can multiply polynomials. So we might have a monomial with a trinomial or a monomial with a binomial, but we're going to take polynomials, multiple terms, and multiply them together. There are no key terms because we already know what polynomials are, binomials, trinomials, and we already know what the word multiplication is. So there's no key terms today. So it says, what is the product of negative 4x to the third and x squared plus 3x minus 4? So product is multiplication, because obviously 7-2 is multiplication. So we have a monomial multiplied by a trinomial, right? 1, 2, 3. So when we do this product, what we're going to basically do is, in a sense, distribute. And I'm going to take this term and multiply by every term inside of here. So it'll kind of look like this. I'll go negative 4x to the third, and then I'll multiply it by x to the second. I will then add negative 4x to the third. It's like distributing times 3x. And then I'm going to put a plus sign for now because I don't know what the sign is going to be. Negative 4x to the third times negative 4. And I took the negative because of this, right? So basically, I'm taking this and multiplying here, and I'm taking this and multiplying here, and I'm doing it here as well. All right, pause, phone call. All right, back to it. So we're distributing. So what I'm going to do is look at the constants. So this constant is 1, so negative 4 times 1 would just be negative 4. And then remember product of power rules, we just add these together. So that's why exponents, we had to do exponents first before we did 7-1, because we had to apply them. So this will become x to the 5th, because there's 3 here and there's 2 here. Remember when we have the same base, we just add our exponents. So then we do the same thing here. Negative 4 times 3 would get me negative 12x. And then again, I'm going to add, there's 3 here, there's 1 here, so it's x to the 4th. Okay? And then the last one, since there's only a constant with a coefficient, we're going to go negative 4 times negative 4. That is, in fact, a positive 16. And then there's no other x, so it just becomes x to the third. And that is our product of negative 4x to the third times x squared plus 3x minus 4. It's just distributing. So instead of saying what is the product, we can write it like this, right? And so same idea, we're going to just distribute. So this time I'm not going to write it all the way out like I did in the last one. I'm just going to draw my arrows, okay? So negative 2 times 1 is negative 2, and x squared times x squared would be get x to the 4th, okay? Negative 2 times 3 is negative 6, and negative 2 times x would get me x to the third because there's 2 here and 1 here. And then negative 2 times 4 is negative 8, and then there were no x's, so I just leave it x squared. I didn't even draw all of my arrows. Sorry about that. Whoa. That was weird. Let's try that again. There we go. All right. So there you go. That is the product of those two polynomials, a monomial against a trinomial. So it says, how is multiplying binomials like multiplying 2-digit numbers? So we are going to multiply 15 by 18 using what's it called? This is called like a table method, or I like to call it the box method because I'm using boxes. And we're going to show you how it applies to multiplying these binomials. Oh, geez Louise. Alrighty, so this method is what I do is I break up the number 15 to 10 and 5, right? Because that's 10 and 5. And then same thing here, it's 10 and 8. And what I do is I just multiply the numbers to fill this box. Oh, sneeze didn't come out. Oh, ow. So this is 100. This is 80. This is 50. And this is 40. And then what I do is I just take all of these and add them together. With this case, they're all numbers, so I basically am doing 100 plus 80 plus 50 plus 40. Okay, so I just add them together, and when I add these all together, I get 270. When you multiply two numbers like this, two digit numbers, this is basically what you're really doing, right? We multiply and then we add, right? You do the same thing. It's just different, breaking it up into place values instead of in lines like we do. But this is actually exactly the same thing that you do when you multiply two-digit numbers. So how does that apply to binomials? Binomials are two terms, so 2 digits, 2 terms. And so we set it up the same way, x and 5, x and 8, and I do the same thing. X times x is x squared. X times 8 is 8x. X times 5 is 5x. And 8 times 5 is 40. And I do the same thing. X squared plus 8x plus 5x plus 40. And I combine the things that I can in this case. The only things that can be combined in these two, or in this one, is these two, right? And that's because these are the only ones that are like terms. Here we added all of them because they were all like terms. Constant, 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 constant. Here I have an x squared, an x, and a constant. So my final answer becomes x squared plus 13x plus 40. So that's how we multiply binomials using what I like to call the box method, or they sometimes call it the table method. So there's another way you can do it. How can you use the distributive property to rewrite this? So instead of using the box or the table, we use a different method, which is distributive property. And what it kind of looks like is you take this and multiply it to everything in here, and we take this and multiply it to everything in here. So it kind of looks like this. We're going to go 2x times x minus 5. And then we're going to add, because it's also a positive, 4 times x minus 5. So it's similar to what we did at the beginning, a monomial times something and a monomial times something, right? So we just break it up. And so now I distribute here. So I get 2x squared minus 10x. And then I'm going to distribute here. And I'm going to go 4x minus 20. And then I'm going to look at things that are in common. And you'll notice I have a negative 10x here and a positive 4x here. Notice the middle is again the same. Two things I'm going to combine. I get 2x squared minus 6x, because negative 10 and negative 4 is negative 6. And then I get minus 20. And so that is another way you can do it. Sometimes, old school, I have actually heard of this being called the FOIL method. All right, and it's because it's first two things, see, first two things, and then we do outer two things. See how those are both the outside? And then inner two things, and then last two things. So you can see how it works. First, outer, inner, last. Okay? So we can talk about that a little bit later too, but that's what I used to call it. Alrighty, so actually I'll do it here. I'll do the FOIL method, what I call FOIL method here. So this is the F first. Okay, and this is the same thing I just did on the last one. So I'm going to times 5x with 2x. That's going to get me 10x squared. So then I'm going to do what we call outer. Okay, this is outer. I don't know if it has two t's in it, but that's okay. Because this is the outside and this is the outside. So 5x and times 1 is just 5x. So then we do what's called inner. Oop. Oh, that was weird. Because these are both the inside ones. And so we get minus 8x, because it's negative 4 and positive 2. And then, I'm going to go like this. And then we say last, because it's the last one of each binomial. And negative 4 and positive 1 is negative 4. And then we do the same thing as we just did. Oop, that wasn't a good circling, but that's okay. And we get 10x squared minus 3x minus 4. So you can kind of use any method you want, right? We've got this kind of distributive property where you split it and then distribute. We've got the box method or the table method and distribute. And then we've got what I like to call the FOIL method. And it's first outer, inner, last. Lots of different ways. So it says, how can you use a table to find the product of a trinomial, x squared plus 2x minus 1, and a binomial, 3x plus 4? It's no different than what we just did a second ago, except, so when I go like this and I make my table, here I'm going to have, in a sense, 3. Okay, so here's my boxes. So here I put 3x, and you can see I'm making this very like uneven, and then this is 4. And then I go x squared, 2x, and I'm going to go negative 1. I need to take that negative with it because it'll affect what goes in here. And if you want to finish off the box, you can. Okay? So then we just multiply. So 3x cubed, because x squared and x make 3 of them. 3x times 2x would get me 6x squared, because there's 2 of them. And 3x times negative 1 gets me negative 3x. So you can see it's exactly the same as with binomials, except we have an extra column, right? So then we do 4 times x squared is 4x squared. 4 times 2x is 8x. And 4 times negative 1 is negative 4. We do the same thing we just did when we did the boxes before. It's basically I add all my I put all of them and add them together. So I go 3x cubed, oops, plus 6x squared minus 3x. Then the bottom 4x squared, add it, plus 8x. And then I can even put minus 4 because I know it's negative. And then I'm going to find my like terms. So I only have one of those. Here's an x squared, and here's an x squared. And if you notice in the chart, just a hint, they're diagonally of each other right here. And then I have a negative 3x and a positive 8x. And look at that, they're also diagonally of each other right here, like a little peanut. And then the last one's just negative 4, and it's by itself, as is this. So we get 3x cubed plus 10x squared plus 5x, because 8 and negative 3 is positive 5, and then just minus 4. And there we go. That is how we find the product of a trinomial with a binomial using the table. So what I'd like you to do is try using the table for this. Okay, I'll help set it up, but I'm going to make you guys do it. Here's your little table. This will say 5y. I'm going to put minus 2 here. Make sure you put minus. Extend these. 4y squared, 3y, and negative 1. All right, so I'm going to leave this one blank. I want you to fill this in and get the answer, and we'll talk about it next time. So what is the area of the rectangle? Remember, area of a rectangle is just length times width. So I'm just going to take 2 and 4/10 x plus 4, and I'm going to multiply it and distribute it with x plus a half. So it's no different than what we've been doing, right? It's just distribute, FOIL, table, whatever version you want to use. So I'm going to just distribute this way. So that's going to get me 2 and 4/10 x squared. And then I'm going to do my outers. I just realized I don't have a calculator. Guess what's half of 2.4? 1 and 2/10. I'm going to check just because. Rather be safe than sorry. Yep, 1 and 2/10 x. And then I'm going to do my inners. That's just going to get me 4x. And then I'm going to do my outer, and that's going to get me 2, right? 4 times a half. Half of 4 is 2. And just like everything else, I'm going to get like terms here. And once again, I have to pause. I'm so sorry. So needed today. Alrighty, so once I combine them, whoops, 2 and 4/10 x squared plus, this would be 5 and 2/10 x plus 2. So there's the area of my rectangle. So things to remember is multiply all terms from one to the other, right? So remember to multiply all terms from one polynomial to the other polynomial. Okay, so that's the biggest thing. It's just like when we added or subtracted them, or when we do, you know, any kind of, we always got to remember to do all of them, any distribution. So when we were doing solving equations, we had to distribute. One of the biggest mistakes we always made was forgetting to multiply one of the other terms. Okay, so here's your independent practice. I'm going to let you decide which way you want to do it, table method, FOIL method, or the broken up distributive method. So I showed you 3 ways, so you can decide any way you want to do this. All right, adios, until next time.